In 1859, John Taylor published The Great Pyramid. Why was it built, and who built it? He was the first person to notice that the very simple 14:11 ratio inherent in the basic proportions of the pyramid revealed to an extraordinary degree of accuracy pi and phi. In the century and a half since Taylor launched this most significant quest to prove that the Giza builders had prior knowledge of higher mathematics, Egyptologists still deny there's anything more than coincidence involved. But in a moment, you're going to see for the first time that this seventh wonder of the ancient world has no less than 12 of the most important mathematical constants embedded within its basic proportions: the diagonal, the base, the half base, the side slope, the height, and the corner slope. Now, I'm using just the basic units generally acknowledged to be the original measurements the builders used in royal cubits: 220 half base, 440 base, 280 height. With these basic numbers, the side angle is inevitably 51.843, and these other measurements all follow simply by applying Pythagorean theory. Now, don't panic. I'm well aware that many people have the following reaction when confronted with mathematics. But I'm going to spare you for now. Everything you're going to see is documented in minute detail on a dedicated YouTube channel, so the true nerds amongst us can triple-check the math to their heart's content. The rest of us can relax, just enjoy the ride. So let's get into it. Here's the square root of 2. It's the only one that doesn't involve any proportion beyond the base, so by definition it's 100% accurate. Here's where we find pi. If we add these two diagonals, we get the Euler-Mascheroni constant. It wasn't discovered until 1734. What happens when you invert that? Square root of 3. This is square root of 6, square root of 5. Here's Brun's constant, not discovered until 1919, hugely significant in the field of prime numbers. Here's the Fibonacci constant, derived from a variant of the Fibonacci series. Here's the inverse of the golden ratio, phi minus 1. And here's phi itself from the Fibonacci series. Now, if we take the base and then divide by that phi, we get E times 100, close to 4 decimal places. And finally, here's E minus 1. Utterly unsuspected today of being of any special importance, yet to our purpose right now, it's the most profoundly impactful of all 12. Why? Well, here are the two proportions that produce the E minus 1 ratio, followed by another sequence of proportions in purple. You don't have to do the math, just hold your breath, because the ratios of these proportions are to an incredible 2 5,000ths of a foot and 4 5,000ths of a meter. Staggering. So the three most prominent units of measure are found intimately connected to each other in the basic proportions of the pyramid, and in the same place where we found the 12 math constants. Let's put this into perspective on a timeline from the beginning of creation all the way up to the present day. Not to scale, of course, but you get the idea. Here's where Orthodox Egyptology states that the pyramid was built, 4th dynasty, and here's where some of us believe is more realistic, around 13,500 years ago. I want you to ask yourself, which came first, the constants or the pyramid? Well, the very definition of a constant is that it stays the same for all time, right? At the moment creation comes into being, there's duality. The constants must exist. Is the circle's circumference ever going to change in relation to its diameter? No. Okay, the constants came first. So, is it reasonable to conclude the pyramid might have been built precisely as it is in order to preserve knowledge of these important mathematical building blocks of creation? No, not at all, says Egypt's Supreme Council of Antiquities. Mankind hadn't even invented the wheel yet, so the Egyptians couldn't possibly have known pi. It's just
sheer luck.
Well, okay, let's grant them that argument. The angle may have been chosen purely by accident. But apparently, the blueprint for the three major units of measure, the imperial foot, the royal cubit, and the French meter, is inherent, embedded in the very same proportions. Well, let's ask the same chicken and egg question. Which came first, the units of measure or the pyramid? Now, this is a little trickier. The constants have to precede everything else, but the way in which we measure those constants, that's surely arbitrary. A decision made at some point along the timeline by man himself, no? Well, we know from observation that the pyramid was certainly built with knowledge of the royal cubit, so yes, that unit of measure predates the pyramid. But as we well know, feet came much later, about here, and the meter here. And of course, Egyptologists fight relentlessly over this. They're constrained to answer that the foot and meter came after to preserve their status quo. So what to make of the fact they're all here to such an extraordinary precision? Same answer from the Orthodox camp.
Luck.
But is it really? We need to think about this some more. If we reduce the green, foot, to unity, the red measures 1.718 feet. This is actually the structure of Euler's number E, the ratio 1 to 1.718. And so the cubit is E minus 1. This is the relationship between foot and cubit. Jacob Bernoulli, in 1683, working on compound interest, discovered this formula, the same one that banks use today to calculate the interest we owe on our credit cards. 1 is the amount that we borrow, and if we're compounding at 100% interest continuously, the maximum possible owed on a loan of $1 converges to 1.718, and the total is E, 2.718, and that's the total owed to the bank. This rate of growth is inherently built into creation. It's the natural base of logarithms. The incredible thing is, this implies the foot is synonymous with the principle, the original unity, what we start with. And the cubit, the interest or growth. And it doesn't only apply to banking. It shows up in calculus, probability theory. It's used to predict population growth, or the rate of spread of an epidemic. Its inverse is the rate of radioactive decay. It's everywhere. Newton found the same thing in 1669 with this infinite series of what's called reciprocal factorials. They're on the bottom with the exclamation points. They simply mean 1, 2 times 1, 3 times 2 times 1, etc. to infinity. And this part of the series converges to 1.718, and there's the 1, unity, preceding it, exactly as in Bernoulli's formula. Haven't we always been taught that the foot was based on the average size of a human foot and the cubit on the distance from the point of the index finger to the elbow? And doesn't such an arbitrary choice sound bizarrely unscientific? Especially now that we see beyond doubt they're both based on this mathematically significant relationship, the universal constant of E. So what about the meter? By reducing it by the same ratio to match the unity foot, we discover this meter is the equivalent of 3.281 feet. Now, is there any mathematical connection between it and the cubit? Well, the French derived it from 1/10,000,000th part of the meridian of the polar circumference. At least that's based on the science of geodesy, measuring the actual size of the Earth by the inherent geometry of circles. Perhaps we should look at other reliable, consistent attributes of our planet, like the 12 hours of day and the 12 hours of night that mark the Earth's rotation, or the 12-month seasons of its yearly revolution of the sun, which gives rise to the 12-month zodiac signs of the constellations. which themselves embody a retrograde pattern far more mysterious to track, but which the ancient Vedic scriptures declare is based on a series of seasons, if you will, that take our planet through an inconceivably long cycle in multiple increments of 1,200 years each for the Iron Age, 2 times 1,200 each for the Bronze, 3 times 1,200 each for the Silver Age, 4 times 1,200 each for the Golden Age, and which altogether constitutes Plato's great year cycle of 12,000 years ascending and 12,000 years descending. The question is, do we see a reflection of such patterns anywhere here in the meter